Hello U12 and welcome to our next video here for graphs and equations. Today we're looking at regions in the coordinate plane. This is a bit like how when we've drawn intervals on a number line, except we're extending into two dimensions. We're going to sketch any functions that we have. We're going to determine whether that line that represents the function is included or excluded. If it's included, we draw it as a solid line, excluded as a broken line. And then we're going to see which regions of the number plane are included in that equation. Now, I think the best thing to do is to jump into some examples again. So to begin with, we have x is greater than or equal to 1 over y. Now consider this as the same function as y equals 1 over x, and that's what I want to draw. But because it's greater than or equal to, I know this is going to be a broken line. So hopefully my drawing's working. X and y axes, and in fact I know that they are asymptotes and that they are undefined. Anywhere where x equals 0 or y equals 0 is undefined here. So that's going to be a broken line because my region definitely isn't going to include either of those axes. Now the function, because it's equal to a solid line, it will include that. Okay, two arms of that hyperbola, and we should be able to determine that this divides our number plane into 6 regions. Right, here's a point in one and another. There's this region here and this region here, this region here and this region here. Now this is a fairly complex example to begin with. And what we're going to do is we're going to test all 6 regions to see if they're included or not. So let's call this point 2, 2. This one a half, 0.5, 0.5. We might call this one negative 1, 1. We might call this one 1, negative 1. This negative half, negative half, and this one we're going to call negative 2, negative 2. Okay, now I've chosen those points because they are clearly representative of each of the regions. We've already determined that the asymptotes won't be included, but the line representing the function will be. Now, if I consider the point 2, 2, if x equals 2, is that greater than or equal to 1 over 2? Yes, it is. So this region here, I'm going to get rid of that little point there now. So this region here, we can indicate shading like this. This region here, above the function, is included. Now, what about 0.5, 0.5? Is 0.5 greater than or equal to 1 over 0.5? 1 over 0.5 would be 2, and a half is not greater than or equal to 2. So this region here, between the asymptotes but under the curve, not included. Now just because, oops, oh dear, hang on. Still getting used to the pen here a bit, I'm afraid. Just because one side of the line is included doesn't mean the other side won't be. Now, negative 1, 1. Is negative 1 greater than or equal to 1 over 1? No, negative 1 would be less. So this region here, this nice rectangular region here, isn't included. Negative 0.5, negative 0.5. Negative 0.5, 1 over negative 0.5 would be negative 2. And negative 0.5 is greater than negative 2. So this region here is included. Okay, 2 to go. 1, negative 1, if x is 1, is that greater than or equal to 1 over negative 1? 1 is greater than 1 over negative 1, so this region in here is included. Okay. And what about negative 2, negative 2? Negative 2 is the x. 1 over negative 2 would be a negative half, and that's less than... Negative 2 is less than a negative half, so this region down here isn't included. Whoops, let's delete the line here again. Okay, so that is the region represented by that inequation. X is greater than or equal to 1 over y. Is that all those regions there? Righto. Next up, our second example here has the union of two regions. And the union is like or, so either or. Our first function, y is greater than x squared. Because it's strictly greater than, I'm going to use a broken line. That function looks a bit like this. My axes, x and y here. And then y is less than or equal to 2. So I think this can be a solid line. I just label these. Y equals x squared. And call this y equals 2. Now, I'm not going to test the regions this time. Really, this only breaks it up into, I suppose, 1, 2, 3, 4, all of this under here, 4, 5 regions. But I'm going to work this a different way. Y is greater than x squared. Okay, remember this is my y-axis. So I want all of everything that's above that line there. Now it's a union, it's either or, so I can include the overlap here. And y is less than or equal to 2. This time I want everything underneath that line. So, all of this as well. Yeah, so that's the union of two regions. Now I should check where these two functions intersect. At these points here, will they be included? Because it's a union, then it's an or, and at least one of them exists. So they're closed circles at the junction of those. Rightio. Now one to go. This one here is a little different. An absolute value is less than 6. Now remember the magnitude of this is less than 6, so I can write it like this. I can say negative 6 is less than 2x plus 3y is less than 6. Now, if I sketch 2x plus 3y equals, that is 2x plus 3y equals negative 6, then we can either find our intercepts there, or we could write that in gradient intercept form, which will be y equals negative 2 over 3x minus 6. That'll be one of our functions. And the other one over here, we've got 2x plus 3y is less than positive 6, which means that y equals, I'm going to get rid of that equation there. Let's just say equals 6. And y equals negative 2 over 3x plus 6. That should be a 2 minus 2 plus 2. Oh, yeah. Now, what do those two functions look like? Here's our axes, x and y. Now, we've got a negative gradient, an intercept of plus 2 and negative 2. So, strictly, right, so it should be a broken line, not including the line. I don't get a pair of parallel lines. Same gradient, different intercept. So this one here is, let's call that y equals negative 2 over 3x plus 2, there is 2, and y equals negative 2 over 3x minus 2, so it's minus 2 there. And I'm looking for the region between those two lines. So 2x plus 3y is between. So I'm after, how are we going to hash this? This way. I'm after this region here, right, in between. If you're not sure about that, look, I'm even going to cross-hatch them just because it's a bit confusing on the angles. Test the origin. Right? If I have the point 0, 0, 0 plus 0, the absolute value of 0, is that less than 6? Absolutely it is. So the origin is very clearly within that region. We've got 3 regions there. The one that I want is this one here. Rightio. We could test something further out here if you wanted to go 2, 2, for example, or negative 2, 2. Negative 2, negative 2. Would test those, but we can be fairly confident that that's the region we're trying to describe. Righto. That's it for regions in the number plane. They can be a bit slow and tedious, but draw the functions, test the points. We'll get you out of trouble. Okay. If you've got any questions, make sure you ask me in class. I'll see you then.